In this video, we're going to learn how to determine the number of rectangles in the given figure. Notice it's the same figure as in the previous video, except that we're not just looking for squares, a particular rectangle, but also looking for all kinds of rectangles. We know square is a particular rectangle in which the shape looks like this. Okay, these are squares, we assume, or it's a bigger square. Basically, a square in this case is where the number of rows and the number of columns agree, right? It could be something like this, right? We determined that in the previous video. However, a rectangle that is not a square may look like this, in which the columns and rows don't agree, right? You have only one column and 3 rows, all right? Or it could look something like this, right? That's not a square. Or it could look like this even, right? Or it could even look like this. Basically, there are all kinds of rectangles that you just can't count by hand. So what we're going to do, we're going to start at the largest possible rectangle. Okay, this is a square, but all squares are rectangles as well, right? So this is a special kind of rectangle. And there's only one possible like that. Okay, there's only one possible like that of this size. You can't move it anywhere, right? It already fits in itself. It's inscribed into itself. Okay, now what happens if we're just gonna move this vertex? So we already covered this vertex. How about we place a vertex here? Okay, so basically we have this size. All right. How can we move this particular size without changing the size of this rectangle? We can move it to, we have 2 positions, here and here. Okay, so basically we can move it down 1, so that's 2 positions down. But also we have 2 positions going to the right, 1 and 2. And notice that this product rule that I'm using accounts for all possible positions for this particular size rectangle, because we can have it 1, 2, 3, and 4, right? And this accounts for 2 times 2, right? This is the product rule that makes it really fast without having to count all the positions. Now let's erase that. So we have a vertex here. Now you only have 2 positions going down, 1 and 2. However, you have no position going to the right, because that's as far as it gets, speaking of the horizontal dimension, right? That's the largest it could get. So it means that there's only 1 position. Okay, so now we're going to have vertices here. Okay, we cannot go down, there's only 1 position going down. However, we can go to the right because there are 2 positions going to the right. Okay, so we have 1 times 2 as the product rule. Okay, so now we took care of all these vertices, so we can go ahead and jump to the smaller version. Okay, we have a smaller version across the diagonal line. So now how many ways do we have in moving it? So we know that we can have 1, 2, 3 positions going down, and we have 1, 2, 3 positions going to the right. Okay, we took care of that vertex, so let's label it with red. We have 3 positions going down and 2 positions going to the right. So it's 3 times 2, the product rule. No positions to the right, but 3 positions going down, right? So 3 times 1. We can go 2 down, 1 and 2 versions. But we have 3 versions going to the right. We took care of this, so now we have one last size of this particular caliber. So now we cannot go down, so it's just going to be 1, but we can go 3 to the right, 1, 2, 3 positions. Okay, so basically now we took care of that. Now you're going to do this forever. You're going to do this forever if you try to get all the way until the very end, because your number of combos will only increase as you decrease the shape of the rectangle. Right? You will have so many different vertices that you'll have to take the combos, take care of those combos. So now the reason why I'm doing this is to show you that there is actually a pattern. If you notice this pattern, notice that you have multiple products that are essentially the same. You have 2 times 2 product. This can be written as 1 times 1 product, right? And you have 2 times 1 product, 2 of them. 3 times 2 product, 2 of them, 1 times 3 product, 2 of them. Precisely. So what that tells me is that we can make it look like 1, starting the 1 in each parenthesis, then add 2, Notice that we'll have 4 products. 1 times 1, which is 1. 2 times 2, that's 1 product. 2 times 1, 2 products. And that's exactly what we have here. If we add the third number, we will have more products. We'll have 3 times 3, as it says here. 3 times 1, 2 of them. That's exactly what you see there. Okay, and then 2 times 3, 2 products, 2 times 3, which gives you 6, right? 2 times 3, and then that 2 times 3. So that tells me that there's a pattern. There's a pattern until you get to the m, and here until you get to n. All right? So the difference here is that m will be the number of rows containing the squares. As you can see, there are 8 rows here. And the n will be the number of columns containing the squares. As it happens, the number of columns and the number of rows here is absolutely the same. It's 8 and 8. But this formula will be useful, I mean, we'll get to the formula. It will be useful for any size m and n. Okay? Notice that this is a summation because whole numbers summed up from 1 to m can be expressed as m plus 1 divided by 2. And then we're multiplying it by this same summation involving the n. So it's going to be n times n plus 1 divided by 2. So what this should give us is mn, the product, times n plus 1 times n plus 1 divided by the product of 2 and 2, which is 4. Right? So this is a very good formula that we arrived at that will tell us the number of rectangles in any shape, whether it's a square, whether it's a rectangular shape, any kind of shape that this larger figure presents. This is the formula that you will use to find the answers to, as long as you know what the m, the number of rows, and n, the number of columns. So in this case, m is equal to 8, right? Because we know that there's 8 rows. And n is equal to 8 as well here, right? There's going to be 8 columns here. So now the sum of rectangles will be easily found by using this formula. Okay, so let's sum them up. That's going to be 8 times 9 times 9, right? Because you're getting one higher each time here. Higher than m and higher than n. You divide that by 4. 8 divided by 4 is 2. 2 times 8 is 16. So 16 times 81, which gives us 1,296 rectangles. I hope this was enjoyable. Thanks so much for watching. Please use this formula at any time if you're ever going to need it in real life situations. And I'll see you in my other videos.